Hello, we are Group 13 presenting the Object Detection Drone. My name is Jacob Bendel and I'll be introducing our project. The Object Detection Drone is a quadcopter drone with object detection capabilities. The video is transmitted from the drone down to our mobile application where we offload the computer vision tasks. We divided our project into 4 subsystems: the drone subsystem, the flight subsystem, the power subsystem, and the detection subsystem. The remaining team members will talk about our experiences and briefly touch on each.
Hi, I'm Anthony Pinessa. I worked on the detection subsystem and the ground control system of the project. Our group was able to collaborate and achieve successful teamwork by holding weekly meetings over Zoom. We also utilized Google Docs so each member could contribute to papers or presentations without us needing to meet in person. If we needed to discuss something and were unable to hold a meeting over Zoom, we would utilize Discord as our text group chat. Since one of the group members had equipment at his house, we would leave the hardware there and meet up when we were working on assembling the drone. That let us not have to travel to campus and reserve a time in the lab. We were able to work on the building of the drone when we wanted or with shorter notice. We learned that the weekly meetings and keeping up with the meetings increased our teamwork along with holding each one of us accountable on our contribution to the project. We will be able to apply that to our future work by already having the experience of working as a team and being able to hold the other members accountable so the work is finished on time.
I worked primarily on the software development for the mobile application of our detection system. We can see an aerial video from one of our drone's test flights. This video is saved local to the mobile phone where our pilot application will parse it into frames. Our detector model then runs in the background to detect people and saves a processed video for viewback at a later date.
In our senior design project, we opted to model most of the quadcopter drone in SOLIDWORKS before any construction was done. The modeling was made as accurate as possible to better visualize the placements of the selected components and create a design that would meet expectations. The decisions on one part of the project factors into other decisions of the project, and modeling everything out in SOLIDWORKS helped speed up the process and create better decisions. An example of this is the decision to use PVC as the frame material. This decision snowballed to the use of the A-frame design as it provides enough space for the components and can easily be constructed with PVC. The size and weight of the entire frame factors into the selection of the motors and propellers and that to the battery selection and so on. Along with the use of a 3D printer, we were able to rapid prototype custom motor mounts and body plates and create a design that best suits our project's needs. This group was created through our shared interest in drones, and this interest kept us focused throughout the completion of our project. This amounted to a drone that can fly and a project we can be proud of.
The main difficulty we encountered during building our drone was version 1 of our PCB. After we received it and tried testing it, as soon as we connected the battery to the PCB, one of the traces ended up burning, and we also ended up with a burnt capacitor. We weren't sure what the main cause of the problem was, as we were all new to designing PCBs, so we had to look for help. After searching around the area for someone to help, we found a company called Fermitron, and they're an electronic product development company. And they also deal with manufacturing and diagnosis. They were kind enough to help diagnose the issue with our PCB, and it turned out that the traces were too thin to accommodate for the high motor current draw, and the decoupling capacitors were also not connected the right way. So to fix the problem, we redesigned the PCB. We came up with a version 2 of the PCB, which offered thicker traces to accommodate for the high current draw, and also the decoupling capacitors were connected the right way. And instead of going with 1 ounce copper thickness, we went with 2 ounce copper thickness, which would also help accommodate for the high currents, just in case. And the top and the bottom layers of the PCB were made as heat sinks, and with a 2 ounce copper thickness, that would help even more.
Overall, we had a lot of feedback both internally and externally. We took this feedback and applied it in a holistic way. If it benefited the project as a whole or was key to a specific important task, it was integrated into the object detection drone. When taking a look back on the entire process of the project, it was great to have such an excellent team who were all interested in drones and computer vision. It created a central focus that we were able to carry through till the end of the project.